Now we're going to jump into Limaçons. The word, this is from the textbook. The word Limaçon is Old French for snail, a name that describes the shape of the graph. As I mentioned earlier, the cardioid is a member of the Limaçon family, and we can see the similarities in the graphs. The other images in this category include the one-loop Limaçon and the two-loop Limaçon, or inner-loop Limaçon. One-loop Limaçons are sometimes referred to as dimpled Limaçons, and that occurs when 1 is less than a over b, which is less than 2. So what that means is a is going to be bigger than b. And convex Limaçons when a over b is greater than or equal to 2. Formulas for one-loop Limaçons. The formula that produces the graph of a dimpled one-loop Limaçon are r equals a plus or minus b cosine theta, and r equals a plus or minus b sine theta, where a and b are positive, and again, a over b is between 1 and 2, and a over b is greater than 2. So we saw earlier when a equals b, that was what we saw up here with our cardioid. But in our Limaçon, this is when they're not equal and a is bigger than b. So we have this type here that's r equals a plus b cosine theta, looks something like this. R equals a minus b cosine theta, looks like that. R equals a plus b sine theta, and r equals a minus b sine theta, excuse me. So how to sketch the graph of a one-loop Limaçon? Test the equation for symmetry. Remember that failing a symmetry test does not mean that the shape will not exhibit symmetry. Often the symmetry may reveal itself when the points are plotted. Find the zeros, find the maximum value according to the trigonometric expression, make a table and plot the points. So in this we're going to be looking at graphing a regular Limaçon, then we're going to look at the concept of multi-loop Limaçons. I'll see how long this video is. We may break this up into two. So graph the equation of r equals 4, sorry to make it jump around, 4 minus 3 sine theta. So we're going to expect it to come down here. That was that pattern. Okay, so for symmetry, it's not going to do well with any of the tests, so it's not going to be passing this symmetry here, here, or here. So let's just go ahead and move on to plotting points, is what I usually do with these. So we'll go with theta. Oh, my pencil fell asleep. Theta. Then we'll do sine theta. Then we'll do 3 sine theta. Then we'll do 4 minus 3 sine theta, which is our r, of course. Okay. So this one, we're going to probably need to go the whole way to 2 pi. So we're going to go 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6. What's the next one? 4 pi over 3, 3 pi over 2. And I need to find a place to do the next set of values. So let me do these, and then I'll look at doing the next set. Okay, so sine of 0 is 0, still get 0, and then 4 minus that is 4. Sine of pi over 6 is 1/2. 3 times that is 3/2, and 4 minus that is 2.5. So this is going to be square root of 3 over 2. This is going to be 3 root 3 over 2, but 4 minus that is going to be 1.4. This is going to be 1. This is going to be 3, so this is 1. Sine of 2 pi over 3 is square root of 3 over 2. 3 times that's 3 root 3 over 2, and then 4 minus that is 1.4. For 5 pi over 6, get 1/2. 3 times that's 3 halves, and then we get a 2.5 out of that. That's 0, 0, and 4. 7 pi over 6 is going to be negative 1/2. So that's going to be negative 3 halves. But 4 minus negative 3 halves is going to be 5.5. Should count this 1, 2, 3, 4, 5. We're going beyond the 5. This is going to be negative square root of 3 over 2, so sine of that. So negative 3 root 3 over 2. And as a decimal approximation, we are looking at 6.6. Oh man, we're getting out there. Then for 3 pi over 2 is negative 1. 3 times that's negative 3, and 4 minus that is 7. I wonder if we should rescale this or just go with, I think we'll just go with what we have. Okay, let's finish this off, theta, and I'm just gonna do this quickly. R equals 4 minus 3 sine theta. So what do we have left? We had 5 pi over 3, 11 pi over 6, and 2 pi. So sine of 5 pi over 3 is going to be negative square root of 3 over 2 times 3. So it's basically going to be this case right here. So we get a 6.6 again. For 11 pi over 6, it's going to be kind of like the 7 pi over 6. So we're going to get ourselves a 5.5. And then for 2 pi, that's just going to be like pi or 0. That's going to give us a 4. Okay, so let's start plotting this. We have 0 is at 4. And then we have pi over 6 is at 2.5. And then pi over 3 is at 1.4. And then pi over 2 is at 1. And 2 pi over 3 is at 1.4. And then 5 pi over 6 was at 2.5. And then at pi, we're at 4 again. And then at 7 pi over 6, we're at 5.5. So we're shooting out here now. At 4 pi over 3, we're at 6.6. So like, let's call that 6, call this 7. So right about there. We'll call this 6, call this 7. Because at 2 pi over 3, or sorry, 3 pi over 2, excuse me, we're down here. And then we're here, 6.6, then 5.5, then back to 4. So the shape we're getting is something like this. Without the shaky hand. There you go. Okay, that was kind of fun. I will make a separate video for multi-loop Limaçons.